Good morning, everyone. Thank you for coming.
Good morning.
Turned out to be a bit sweatier than I expected. So a couple of things just before I really get going. I need to acknowledge the support of my current employer, New Relic, and my previous employer, Swift, without whom I would actually still be in Vancouver and not here delivering this talk, so thank you very much. More importantly, I also need to say that every single thing I say from here on out is not endorsed or approved by either of them, so I am actually speaking for myself. So, Android. We have this interesting Linux-based operating system that has basically taken over the world in terms of mobile devices, phones, tablets, and so on. And the usual way to develop for it, of course, is through the Android SDK. So you write some Java code or something else that ends up as Java bytecode, and it becomes an app, and all is shiny, and hopefully you have users. And that's great if you're actually supplying Android devices to end users. But a lot of the time you might want an embedded box, and the initial inclination is to maybe reach for something that's designed for embedded, or maybe you get an Arduino. Please come in. Maybe you get an Arduino, maybe it depends on kind of what level of power you need. Maybe you try and cram everything you need in some sort of custom enclosure. But we've got this Android thing, and it's available in such a wide variety of form factors nowadays. You have this diversity. I mean, you have phones. That's where it started. You have tablets. You have this weird thing that Lenovo announced last week, which is basically an all-in-one computer with a 19-inch screen. You have gaming consoles. They're actually pretty cool. And you also have a whole bunch of different devices made by about 10,000 different Chinese OEMs, which range from HDMI sticks to set-top boxes to pretty much anything else that you can imagine. They scale up, they scale down. You can get tiny little things. So if you're looking at doing things like home automation or, I don't know, also anything in the workplace where you need to put something in, set-top boxes to run TV displays, something like that, Android becomes a viable choice. Now, you may be able to do all of that with regular Android applications, but you may not. You may want to develop a daemon of some kind, or port an existing daemon of some kind, and you may not want to actually have it depend on Android having started up its user interface and being touchable and interactable. So in that case, why not take all of these layers? It may just be that you only really care about the kernel and the C library. So as I said, if you want to run native code, you've kind of got two options. You can invoke native code that's compiled using the native development kit from a regular Android app, or you can just, particularly if you've got root access to the device, why don't you just build your own binaries and run them via init, same way you would on any regular Linux box. Because at the end of the day, it's really just a weird, slightly substandard Linux distro. The advantages of running as a service are numerous. You can start earlier. You don't depend on Surface Flinger actually starting up. You get better. The Android out-of-memory killer, of course, is heavily tweaked to reap activities in the background that aren't being used. If you start from init, then you don't have to muck around with the proc file system to actually get sensible out-of-memory behaviour, so that's also a bonus. Most importantly, and this wasn't on the list of selling features when I was selling this project to people at work last year, it's fun. It's, writing stuff in C is fun, at least I think so. And writing stuff and treating Android as basically a Linux distro is also fun. It's kind of more, certainly for me, it's more what I'm used to. My background's in web and system dev. It's not in mobile phone apps. It's not in shiny GUIs or anything like that. So for me, this is fun. So you have your Android device. You've picked something. You've gone to the million trade fairs in Hong Kong and Shenzhen and everywhere else, and you've picked some sort of device that actually is the form factor and has the connectors that you want to. At that point, how do you access it? Now I'm going to skip over ADB reasonably quickly. I suspect most people probably already know the basics of ADB. ADB, for those who don't, is basically the command line tool that interacts with Android devices in USB debugging mode, such as this one. ADB actually comes with a ton of commands. There are commands to do all sorts of interesting things. My experience is that in practice, the ones that you actually use for this sort of work are basically shell, push, pull, and forward. Shell, as the name would suggest, basically gives you a shell on your device. It's usually MK shell, which is the MirBSD corn shell implementation. Not my favourite shell, but it could be worse. It could be C shell. And you get an unprivileged user by default. Now, if the device is rooted, you can su to root. In practice, to do this sort of work, you need to have your device rooted. Of course, a lot of this sort of more OEM-y hardware tends to come pre-rooted. You don't really have to worry about that. If you have a Nexus device, it's pretty easy. If you have a Samsung or HTC device, good luck. But there's usually a way to do it. Push, as the name suggests, pushes a file to the device. Pull pulls a file from the device. And forwards a TCP port. And obviously, if you're doing any sort of network type daemon, then that becomes super important very quickly. The syntax is a little bit weird, but it is actually good. It's more flexible, and it can do more than just TCP, but realistically, that's what you would use it for 90% of the time. So once you've shelled in, you get this MK shell, and basically all of the rest of the userland tools, instead of the GNU tools that most of us are very, very used to, you get Toolbox. Toolbox was so Google attempted very hard to minimize the amount of GPL code that they put into Android. Basically, apart from the Linux kernel, there's effectively none. So BusyBox was the obvious thing to put on there for the userland tools, but BusyBox is GPL licensed, and the copyright holders of BusyBox are quite litigious, and therefore they needed something else. So they wrote Toolbox. It doesn't include a shell, they use a separate one. It basically re-implements a subset of what BusyBox or a regular GNU or BSD userland give you. There's about 70 odd things. Unfortunately, it does most of them quite badly. So my advice is, and there's also some, actually I should go back to this for a second, there are also some really weird omissions, like there's no tar, for example. So if you want to get a directory off and on a device, and you want to do it with permissions, all of a sudden it becomes quite a bit more difficult. So, as I said, not a great set of tools, kind of crappy. The good news is that there are basically BusyBox compiles for pretty much every architecture Android runs on. And you can always build it yourself if you really want to. So my first order of business and suggestion would be if you want to start hacking on your Android device, maybe put BusyBox on there and save yourself a lot of hassle. The file system is quite different to what we tend to be used to in desktop distros. These are kind of the key bits that I'm going to touch on today. /data is effectively the persistent data partition for Android apps and their data, and some of the configuration data. So for example, when you turn on a Wi-Fi hotspot on your phone, internally it will spin up DNS mask and I blanked on the name of the, thank you, host APD, and all the usual tools that you would use, say, to turn a laptop into an access point. And it puts the configuration files and so on in /data. Init.rc, usually most devices actually have a whole range of init.rcs. Let's log into my phone and see how many we have here. So you can see there that there are actually a whole bunch of init.rcs, and there's the actual init process as well. These are used to control server startup and how they actually operate. The reason why there are several is that some of these are generic and some of these are device specific. So for example, the init.hammerhead.rc. Hammerhead is the code name for the Nexus 5. So therefore that's things that are relevant to that. Such as setting up the debug file system and so on. ADB shell also has this wonderful quality of tending to completely burn your terminal. You get used to it after a while. Whatever. I don't mind having a few more SU processes running around on my phone. /mount, unsurprisingly, is where everything gets mounted. /system is basically where the system tools go. So your bin tools are in system, in /system/bin. In actual fact, let's just go back to the device and have a look at it. System, it would help if I could type. This is like doing live coding yesterday. So you can see there's toolbox. So we've got binaries in bin, there's a user, there's an xbin, which is sort of like sbin, but not exactly, and there's a whole bunch of other random stuff in there as well. So it's sort of, on the one hand, it's kind of like, I guess, /user on a regular desktop distro, but it's not exactly the same. The layout's somewhat different. There is, however, an extra issue with this. Now, Android gets a bit of a bad rap for fragmentation. I think it's somewhat undeserved for the most part nowadays, but Chris will probably start throwing things at me as a userland developer. But one area where you do get serious fragmentation is when you're dealing with devices at the actual system level. For example, let's look at the network interfaces on my phone. There are 21 of them. I've never had another device that had 21. These things with the standard firmware have about 16. 5 on their build because apparently they're awesome. The point is that you do have some things that Android guarantees you at the system level. You will have a C, as long as you know the Android version that you're running, you know what C library you've got, and I will come back to the C library at some length. You know what binaries you've got because there will be toolbox, which means that you at least have at least those tools. So that's a good start. But once you actually want to interact with, say, hardware on your device, it gets kind of interesting kind of quickly. So if you're doing this sort of work, it's really ideally in a situation where you know that you're targeting something in particular. You actually have a device in mind. If you're trying to do something at this level that you want to be able to make portable across a range of devices, phones, tablets, standard consumer devices, stop. Go back, write a regular Java app. Your life will be much better. This is really for the sort of thing where you want to change the temperature on your fish tank programmatically based on the colour of your lights that you got from Moore's Cloud. So there is fragmentation. As I said, partitioning is not terribly standard either. So you've got these directories, as I said, data, system, cache, there's a bunch of others. There's no great standard around how these are done. Most devices will have them come off different partitions on the internal MMC. So for example, on the Nexus, we've got a whole bunch of, so system's a separate file system, data's a separate file system, cache, persist, firmware. The SD card actually isn't a separate file system because of course Google hate SD cards, so there isn't one in there. And you can then see that there's even more noise in terms of there's loop devices and secure devices for secure app storage and things like that. So as I said, it's fairly fragmented. But assuming that you do have your device and that you haven't been scared off yet, give it about 20 minutes, you probably will be. But assuming you're still interested, basically all the tools you need are in the Android NDK, which is the native development kit. This is not a standard part of the Android SDK, it's a separate download on developer.android.com. It's about 400 megs nowadays. It basically includes all of the toolchains required to build apps against every architecture Android runs on for every version of Android that's been released. So you can kind of imagine how it gets fairly big fairly quickly because you've kind of got compilers and linkers and so on for all of those and the standard libraries that got shipped. By default, it's really set up to be integrated with Eclipse and the Android development toolkit. But you can also use it as a standalone toolchain. When you extract it, there is this lovely command here which will make a standalone toolchain. So for example, if you're interested in Android 19, which is 4.4, and you want an ARM toolchain with Clang as the compiler instead of GCC, because I like my error messages to be informative, then you can basically do that, and you will end up with a toolchain. Let's have a look at what that looks like. Let's actually do this properly this time. Okay. Android 19 bin. Okay, so this was the Clang Android 19 toolchain. You can see here that The binary names are mostly correctly prefixed so that you can actually use them with, say, auto tools to do cross compiles without having to do the legwork of actually setting all of that up, setting the environment variables up yourself for all of the binaries. You can see it's actually given me GCC and Clang for some reason. I assume there's a dependency internally that I'm just not aware of. So yeah, you've got this tool chain. It looks pretty familiar if you do any amount of C development or even really just building C programs on Linux. This isn't scary. It's just a standard tool chain which just emits ARM instead of x86 in this case. So that's the good news. Better news would be if I hit the right button. So in terms of development environment, as I said, you can use Eclipse, and I should have put ADT on there as well. Eclipse and ADT will integrate with the native development kit. I personally am not a fan of Eclipse. So what else have we got? You've kind of got the usual set of choices for building any software on Linux. Because you tend to be targeting one device and maybe you have full control over your build environment, a straight up makefile is often the easiest way to deal with it. You can get auto tools to deal with it really nicely because of the fact that the toolchain is prefixed. You can obviously use pretty much whatever you like, basically. But I like makefiles and I like keeping things simple. So there are some gotchas when you're developing C software for Android instead of a regular Linux distro. Because it's kind of, wow, I can't spell. It's kind of enough like the regular distros to be vaguely familiar, but the differences kind of get you in the end. So it's kind of a trap. The big trap is that in another spectacular case of not invented here syndrome due to licensing reasons, Android uses a different C library. It doesn't use glibc and it also doesn't use eglibc, which was probably the obvious choice because they're both GPL licensed. Instead, Android took a C library from one of the BSDs. I have no idea which one. If anybody knows, actually, I'd like to know because I tried to figure out the provenance of this last week and couldn't. And they took a lot of bits out and they basically tuned it just for what Google needed to run Dalvik. And they called it Bionic. Sadly, it is not a 70s TV show. So as I said, forked from a BSD Linux, feature strip. Now, standards compliance is, as I said, spotty. It's C, as an actual C library, it's fine as long as you're doing C89 or C90. C99, eh. But the POSIX side of it is pretty iffy at times. So this obviously provides a bit of a challenge in terms of, certainly my first reaction when I'm looking for, say I'm checking on a POSIX function or something like that, is I just go man function name or apropos some sort of keyword for what I'm looking for. Now on the desktop, of course, or on Linux, regular Linux distros, you know that you've got that function available. You know it probably behaves the way the man page says. Hopefully the man page doesn't say to be completed, which sometimes happens, but whatever. Bionic, on the other hand, does not implement everything, and it does not implement everything correctly. So you get to have some fun. It has a completely custom pthreads implementation that implements about half of the pthreads API. It's mostly the useful half, to be fair, but if you're doing threaded applications, that immediately becomes something that you need to test very thoroughly. So, for example, I'm just going to run through a couple of gotchas to give you a taste of the sorts of things that I ran into when I was doing this work. So as I said, pthreads implementation, get addr info, never accepts flags. My personal favourite, though, was its temp file implementation. So temp file is a standard C library function. Does anybody not know what temp file does? Splendid. So I have copy-pasted the code from Bionic that implements it. This looks fairly sensible. It has a hard-coded temporary directory, which is probably not ideal, but whatever. Tries to get a file pointer from that and returns it. That's fine. This temp file, I'm not going to run through it, it's a bigger function. Anyway, the net effect of this is that I can write the effective version of what temp file in Bionic actually does much more simply. Technically, this is in compliance with the C89 standard. Unfortunately, it's not terribly useful in practice. So that's the thing, that's what I'm getting at about, like, it's insidious. You'll write days worth of code and it will all seem to work fine, and then you find out that it actually hasn't been able to create a temporary file where it needed to, and hence the output of all your long-running tests has been discarded silently. Not that I'm bitter. That was my reaction when I discovered that. So there are many coping mechanisms. I think the big one is whatever you, and this is obvious, and I'm sure everybody here already knows this, but I'm going to reiterate it anyway because I just think it's a good thing to point out. You really want to make your project cross-platform, at least to the extent that it will run on your development machine, which hopefully is running Linux, and your Android device. Especially you want your unit tests to work on the desktop, and you want your unit tests to be good and have good code coverage and all those lovely things that may or may not actually happen in the real world. The reason for this, I guess, is obvious. I mean, it's a way of quickly prototyping. You don't have to worry about going back and forth to the device. It's also a good way of, I guess, finding the bits of Bionic that are probably going to trip you up later. Obviously, it's not, you can't always do this completely. I mean, if you're relying on hardware on the device or something like that, you can only mock so much. But having your key bits of code, at least, and key bits of library interaction working both on your desktop and on your device is useful. Plus, your device is probably a lot slower. Plus, if you run on the desktop, then you've very easily got Valgrind and GDB and Clang's various analysis tools and so on available to you. Another is get familiar with the device that you're targeting. Poke around on it, you know, see how things are actually laid out. Vendors do change quite a lot in some of their firmware builds, so even if you have seen like a few Nexus devices and you think you've got it sorted, then you pick up a HTC One and it's just totally different. Maybe take a backup first though. So in terms of debugging, at some point you're probably going to want to attach a debugger to something that you've written. Now, Android does actually provide GDB server. A standard Android firmware will have GDB server unless the vendor's gone out of their way to remove it. It's fairly difficult to actually use their bundled, even though GDB server is a standard component, it's fairly difficult to use it outside of Eclipse and ADT. The reason being that I don't know what Google have done to it, but it's crashy as hell. And if it doesn't crash, then your GDB multi-arch package on your desktop will probably crash. In actual fact, they usually take each other down at the same time. So, GDB server, it's there. It works 20% of the time, probably, but not the best option. So at that point, what do? Well, hopefully, to start with, you've actually got a fair chunk of you've actually got your code running on your desktop, so you can hopefully reproduce the bug there. But let's say that you haven't been able to do that. Now, I guess the obvious thing that springs to mind is building GDB for Android. I mean, we're building C software, so how hard can it be, right? I attempted to discover this last year. About a week later, I decided that it probably wasn't worth any further time. The problem isn't so much GDB itself, but GDB depends on a whole bunch of other things. It depends on specific behaviour. It just turns out to be a bit of a rabbit hole. So if I can do nothing else in this talk, hopefully I can at least save somebody that week of time. So don't bother. But obviously you still need some way to debug your applications because not everybody grew up with PHP like I did and, you know, just print things out. Basic. It's very basic. Instead, the approach I like to take is building a Debian root file system and running it under a chroot on the device. Debian supports pretty much all of the ARM architectures and MIPS architectures, and obviously supports x86, otherwise we've got bigger problems, that Android run on. Android is still Linux, it responds to the same system calls, so the userland still works. And the really good thing is at that point you can feel the joy of apt-get. If you need software, it's not very far away. The downside of building, this is not free, however. There are some downsides in building a chroot. The first is that you need enough space on your device to have the chroot. This is less of an issue now, particularly on devices that have unified internal storage and don't have SD cards. You know, for example, on my phone, adb shell df. You know, on my phone, basically /system/data. Well, sorry, /data/. Well, /data has 12 gigs. of space. So, and slash data is probably where you're going to put that stuff. So that's not such a big problem. But there were definitely older devices. I had a HTC Desire HD, which was kind of a tank of a device except for the bits that didn't work. But more importantly had only 1.5 GB of internal storage total, and it was partitioned in a really, really dumb way. So you can't do it on that. I mean, you can try and do some, you can try and put it on the SD card and loop mount it, and that, that will work. I've done it. But you kind of have to know your device to know the right approach. I mean, to be fair, the first thing you should do really is actually GDB server. Just because it's always failed for me doesn't mean it's always going to fail for you. Obviously it works for someone. But if you do need to do a Debian chroot, it's not a terribly difficult process. So, I'm going to quickly run through it. The slides will be available. There is actually a really good reference for this on the Debian wiki. If you Google Debian chroot Android, you'll basically get a better version of these instructions. So we have, effectively, the best way to do this is to create a disk image. The reason being that a lot of devices nowadays mount all of the partitions that you can actually write to as no dev, so that makes it a little bit more difficult straight away, and often no exec, which makes life even harder. So this is fairly standard. So you create a disk image, make a file system, loopback mount it on your desktop, and then you run this tool called DE Bootstrap. Now, I'm kind of assuming that you're running Debian or Ubuntu on your, or something else that's based on Debian on your desktop. If you're not, get a VM. If for some reason you can't even do that, then get a new computer and then install Debian on it. You can run DE Bootstrap. -- foreign is the most important part of this, because what happens, DE Bootstrap basically will download all of the base packages for a Debian install, and it will put them into a directory and it will do some initial setup. So there's two stages. There's kind of the download and unpack, and then the actual configuration. Now, the download and unpack will work no matter what architecture you're targeting. But obviously the configuration doesn't work so well, because at that point you're trying to run ARM binaries on your x86 and things fail. So foreign tells it not to do that, just tells it to get all the files and unpack. So tell it what distro you want. I've gone for testing, doesn't really matter. And where you want to push it to, unmount, push it to your device. I pushed it to the fake SD card. Then from there, you can go into the device, make a directory to mount it at, and then you have to do some legwork. Now, I discovered about an hour ago, which is why I was sweating when I got here, because I changed the device I was doing the demo on, that the Nexus 5 no longer has a working LO setup. So it will still work, but the problem is that Android will use loopback devices for the secure storage of secure application information. So you don't actually know how many loop devices are in use at any given moment, hence LO setup. The problem is that, as it turns out, they've now balked LO setup in such a way that it can't actually detect how many loopback devices are in use. So what I've done instead is I've hard-coded it to 255. If there are 255 loopback devices in use, there are probably bigger issues. So we LO setup. The install will not know how to find a name server, so you just put something in there. You mount it, obviously, and then you bind mount dev pts proc sys so that you can run things like GDB, and they can actually attach to processes outside of the chroot. From there, you just do some stuff, you call chroot, and then you unmount and clean up, which is basically the reverse on the way out. Once you are on the device, and you're actually in your chroot, then you run the second stage of DE Bootstrap, and at that point, you have a working Debian install on your phone, or your set-top box, or your little HDMI stick thing, or your giant 19-inch Lenovo thing that nobody will buy. So this obviously gives you a whole bunch of tools. All of a sudden you've got Valgrind, because Valgrind actually runs pretty well on ARM7. You've got GDB. You could theoretically put an entire toolchain on there and just do all your development on the Android device, which if you've got that giant Lenovo thing, hey, why not? Probably don't do that in practice. So let's actually see this in action. I have rather optimistically plugged into the network, and I'm actually going to see if we can do this from scratch. Assuming I find the right command. Actually, how am I doing for time? Oh, not too bad. Best way. Okay, cd temp, dd ifdev 0, bs. Useful. xt4 debian.image, yes I know. What's the worst can happen? Loop debian mount, cd mount. So you have to do this as root because it has to be able to set up the permissions correctly on the file system. That would have, yeah, that failed. hf testing mount, and I have to give it a mirror because I'm actually running Ubuntu. Pub Debian. So you can see here it won't check the release signature. I mean, this is a secure network, right? So nothing can possibly go wrong. It'll retrieve the packages and it'll basically go away, download everything, and create your first stage root file system. I'm just going to see how quickly this starts up, and if it's too slow, then I'll just skip ahead because I do have a couple of these already in action. I think I can. Meh, whatever. Okay. So let's look at one. Here's one I prepared earlier. SD card debian.sh. Okay, so this is running on my phone right now. I'm connected via ADB via this cable, and I have this Debian environment right here. Now, because I've hopefully got the mounts right, and I appear to have, I can still see all of the processes running on the system. So, you know, there's the Urban Spoon background process, Tripit, Firefox, and so on and so forth. So if I've got something running on a system level that isn't working very well, I can now attach GDB using gdb-pid. Because it's in a chroot, I can also, there's a trick to use the ld.so to actually, if you've set the LD library path correctly, and you can then execute files with it that have been shipped within the chroot from outside the chroot so they can access the full file system. I don't have a slide for that. That is actually on the Debian wiki, however, on the same page. So when you're getting the instructions for setting it up, get the instructions for that as well. It's pretty nifty. So I said, all of a sudden, I have GDB. Did I install GDB? I did. I have Valgrind. So when things go horribly wrong on the device, and they will go horribly wrong on the device, trust me, I have at least some tools that I can throw at it that will hopefully give me some idea of where I've messed up. Okay. So that's setting up a chroot. You can see that's still chugging away. I think that was a good decision not to go there. Okay, let's have a look at actually building software for the device. So as I said, I'm just using a straight up makefile because it's simple. This doesn't scale beyond a certain point, obviously, but for simple projects, it's not bad. So what I've implemented is something that was meant to be a fortune cookie thing and ended up as a hello world thing, so I ran out of time trying to fix this device. I'm using a library called micro-httpd, which is a GNU project, which provides a very simple web server that can be embedded statically into a binary. This also means, therefore, that I have to be able to cross-compile it for ARM. So I'm not just compiling my own code for ARM, I have to cross-compile a library for ARM as well. So I'm just controlling all of this from a top-level makefile. So the structure of this project is basically that, I really hope this works, because otherwise I'm going to look like a complete idiot. Okay, so the structure of this project is that I've got one C file, which basically just spins up does enough to spin up micro-httpd, has a handler which basically prints hello, whatever your name is, and a signal handler so that it doesn't run forever, and cleans up after itself and releases the port and so on and so forth. In Vendor, I've got the stock libmicro-httpd tree. This is just, I downloaded the tarball, I extracted it. I haven't built it. So, in the makefile, I've got this set up so that we'll build it both for Android and natively. So for Android, So there's a standard set of configure options. You can see I'm disabling basically everything because I'm not interested in HTTPS, I'm not interested in Speedy, I don't want to run the tests under curl, I don't really want to run the tests at all, I don't need a shared library, you get the idea. I also have to disable epoll because although that works perfectly well on the desktop, that's another thing Bionic doesn't give you. So on Android, basically we create a build directory, we run configure with the host and, well, the correct host to tell it's cross-compiling and the correct C compiler. If I had my path set up correctly, then obviously I wouldn't need to provide the C compiler, but I'm lazy. And it will build. And then native is exactly the same, just without the cross-compilation. All right, let's see what happens here. Please tell me it's in my history. Okay. So this will go away. It will, obviously the library is the dependency, so it will build the library first. We will end up with static libraries for both ARM and x86, and then I will build my application and build that both as ARM and x86 as well. So this is obviously fascinating right now. I really should have given it a -J, shouldn't I? Live and learn. Okay, we're done. So we now have, so the way I've just set this up is we have Android and native output directories. The Android one I really hope is ARM, yes it is. And we've got a native one. So let's run this natively first. Actually, let's run this under Valgrind. Let's see what it does. I haven't done this, so this might be horribly embarrassing. 5, 6, 7, 8. Okay. There we go. So it's running. Hello world. Thank you, thank you. Hold your applause, however. The really good thing about this is it's also given hello favicon.ico as the favicon to the browser as well. Unfortunately, it did it as text plain, so I don't think Chrome knows what to do with it. Okay, so that's, I was going to say cool, that's probably overselling it. Mildly interesting, I guess. Let's push this onto the device and see if we can get it to run. And there is actually an element of see if we can get it to run. SD card fortune, I'm just going to throw it somewhere in data just so that we've got it there. Chmod it, because it's come through the SD card, so it's no longer got an execute bit. Fortune, misc, fortune, P, 8080. Okay, it's running. That's a good start. Now then, I had some difficulty with the network port forwarding. So to start with, let's just prove it's running by prodding it on the device with telnet. Hello. Exit, go. Okay, let's see if I can actually get this running. What's its IP address? Ping. Good start. What did I say? 8080? Okay. That went well. Okay. 8080. And it works. So what this really means is that you can now run a denial of service attack against a web server running on my phone. Excellent. I once saw Jeff Waugh do a demo of in a Node.js talk where he said the Node.js server would scale infinitely. I very quickly proved him wrong with AB. So this is basically an approximation of the development cycle for this. Now, in terms of deployment, you've got a couple of options. You can push to the device like this and just run. If you've got the ability to modify the root file system, then the best way to do it obviously is to put your daemon on the root file system and then add entries to init.rc to control startup and shutdown. That depends on the level of access you have. You could also run it from an Android app which only exists to run on startup and start the daemon. the possibilities are kind of endless. The problem is that you need enough access to the root file system and the device to actually be able to make it persistent, which sometimes you do, sometimes you don't. So choose your device as well. So in summary, doing stuff on Android is kind of cool. We had a demo. You can write C daemons for Android devices. You can actually do useful things. And it's not that hard as long as you're aware of kind of the process and the things that you may run into. I'm almost done, but before, I have a question before. How is the web server responding?
Yep, it's working. Yep.
Awesome. So that's my question for you guys. And now I'm happy to take questions from you. Yes?
Have you tried statically linking to an alternative libc rather than Bionic?
I did actually experiment with that. The issue... Something you want to share, Christopher?
Rarely works.
Fair enough. Yes.
If you could just repeat the question.
Sorry, the question was, have I tried statically linking to a better libc that doesn't suck? I may have editorialized slightly there. The answer is that I did look at it. The problem you have is that, for example, glibc, if you're doing anything network related, it's going to want to load stuff dynamically at runtime anyway, even if you tell it to be static. So you probably can do it if you're very careful, but in general, Bionic's okay enough that you're probably better off just finding shims for things that it doesn't implement properly elsewhere, rather than trying to circumvent the whole C library. Plus, the binaries become huge at that point, which is another problem. Anyone else? Yes?
You said you should use BusyBox. Have you got any thoughts of replacing using the BusyBox install command, the things that come with Toolbox?
So I have seen it done. There are...
L1 there, we do exactly that.
Sorry, the question again was BusyBox instead of Toolbox. Yes, so if you have control over your firmware, you can basically do it and it's fine. Because BusyBox and Toolbox, effectively BusyBox is a superset of Toolbox's functionality. I don't think there are any glaring incompatibilities.
Yeah, when we did it, we've replaced it and we haven't found any issues with conflicts in the init system or anything like that so far.
Yeah.
So.
If you can do it, because Toolbox is crappy. I think there was a question up there.
Have you found the NDK in terms of interacting with, like, using the features of the phone and stuff like that?
Have I found the NDK in terms of interacting with the features of the phone? It varies a lot. So it depends on the device. If you're looking at like a camera, it's probably a standard video for Linux interface and it's fine. You can just use whatever you'd normally use. If you want to interact with Bluetooth, it's used to be a standard stack. It's slightly less standard now. Still not so bad. But if you want to do anything kind of that's really non-sort of part of a standard Linux system, you either end up doing really weird hardware-specific stuff, or probably more likely you'll end up using JNI to call back into Java code to handle it using the Android APIs, which is ugly and horrible, but it's kind of the best way to do it. Yep.
Does NFS work? Can you NFS to an ARM install?
Does NFS work? The answer is sometimes.
We're trying to get that working reliably at the moment.
Yeah, these things actually are supposed to do it.
Just a description of NFS?
Yeah. In theory, yes. Some of the kernels, even that ship with devices, actually have NFS support, I think just because the vendor wasn't cluey enough to disable it. My HTC Desire HD actually had an NFS module. I have no idea why. So yeah, it's theoretically possible. I think in practice there are probably easier ways to go about it. Probably using something like Fuse is probably going to be the better way forward. But yes, in theory, you could. I think I'm pretty close to... All right, yep.
So if you're putting your own server on there, how do you go about stripping out a lot of the kind of Android junk that you don't need?
Well, it depends on. I guess it depends on how far you want to strip this back, right? I mean, if you're at the point where you don't want any sort of Android UI and you don't want any of the features Android provides, you're probably using the wrong device, or you're using the wrong distro, at least. Yeah. In that case, you might as well replace the root FS with Debian. It'll probably still talk to the same kernel, so you'll still get hardware support. And just get rid of the overhead of Android altogether. So there's a balancing act there. I mean, if you really are purely just doing server stuff, then yeah, it's probably not the best option. unless you really can't get it running under Debian, in which case maybe it is the best option. I think we are done. Thank you very much.